Good morning, everyone. Today I have this question. This question is from current electricity chapter from HCV book. It's this question is related to class 12th. I'll be explaining the how to approach this question, and uh, these questions require a bit depth of concepts. You have to apply some mathematical concepts with it. You have to include to solve this question. So, first of all, we have to read the question very carefully. So, what it says is we have given a conduct we have been given a conductor which has a length L, and it has a circular cross section. The radius of cross section varies linearly from A to B. Okay, varies linearly from A to B. Radius is smaller than B, which you can see in the question. If in the question, if you see it properly, A is less than B. So to clear that, I have drawn a figure on the side so that you are able to understand it properly. And we are also said that we are also told that B minus A is less than L, which means if we find the result of B minus A, it will be very much smaller than L. Okay, and we have to find what we have to find the resistance of the conductor, and we are given the resistivity is rho. Sorry, the resistivity is yeah, the resistivity is rho. So sorry, I got a bit confused. So yeah, let's start solving this question. Now, what you have to keep in mind is when you are given uh, a question the where you have to find something which is varying in value. Let's say in this question you have been given A and B, which are varying, which means the radius of this conductor is different at both the ends. Here it's different, here it's different, here it's different, here it's different. So you don't really know where the resistance is what. You are only given the resistances A and B at both the ends, but you don't know what the resistance is here. You don't know what the what the radius is here. You don't know what the radius is here. So for this question, these types of questions, you have to basically do integration. Okay, I hope all of you know what integration is. So let's start solving this question. Now let me take a distance x from A. Let's say this is distance x, and let's take an element on here, which will be a very small length. I will name this as dx. Okay, let me rub this one and this one. So yeah, this is dx. Okay, and let me call this length as y. Okay, and let me take another length from here. So this will be y minus a. This length will be y minus a. If you observe it carefully, this length this length we have found out this length is the difference of y and a. So I've written this length is y minus, and similarly this length this length this length is b minus a. Okay, so here, if we take on this element, on on the on the element, we are getting dr. The resistance is very small here. If we take the element, the dr will be equal to rho. Rho is same everywhere since it's made of the same material. So rho is same everywhere, and rho length, since the length of this element is dx, rho dx by area. This means rho L by A. We know the formula. So area will be pi. Area is the same. Area is circular. So area will be pi. A radius. What's the radius? Radius is y. Okay. Radius is y. So now what we can do is we can do, see, see the question carefully. We have an angle theta here. We have an angle theta over here. Now, if I find out tan theta, tan theta is perpendicular by base, so tan theta will be b minus a by L. It will also be equal to y minus a by x, right? So if we find out the value, x times b minus a be equal to L times y minus a, right? It will be equal to bx will be equal to bx minus ax equals ly minus la. Now what we have to do is we have to differentiate this with respect to y. Differentiate this with respect to y. So we will get the answer as b minus a equals to L dy by L dy by dx minus 0. We have done the differentiation with respect to x, so that we can find the value of dx from here, and we will put the value of dx over here. That's why I have done this. So let's take the value b minus a equals L dy by L dy by dx, and we can find out the value of dx from here. Dx equals L dy by b minus a. So we have, what we have is uh, the value of dx. So we have, or we also have this equation here, which is dr equals rho bx by pi y square. Okay. Now if we just put the value of dx over here, we can get the result, which is uh, rho dx value is L dy by b minus a by pi y square. Okay, now we can take all the constants at a side. So it will be rho L dy by pi y square b minus a. We can take it as rho L by pi b minus a dy by y square. Now if we find r, we have to integrate dr. So I've taken all the constant at the side, so that I can integrate this from a to b. Since we are given in the question, we have to find the resistance from radius a to radius b. So now we have this rho L by pi pi b minus a. For those who don't know how to do this, we can just, let me just show you how to do this. We have y to the power minus 2 dy. Okay, this will be y to the power minus 1 by minus 1. So this is minus 1 by y. So we can just put it minus 1 by y a to b. We what we have is OL by pi b minus a as 1 by b minus 1 by, so 1 by a minus 1 by b. Uh, if Now how did I do this? Now if you solve this carefully, it will be 1 minus 1 by b minus of minus 1 by a. So I've just done, I just rearranged this one, so it gives like this. So this is no rocket science, this is just what I have done in my mind. So now we can find out rho L by pi b minus a, and we can do this as b minus a by ab, say by ad, and what we have is, can cancel b minus n, b minus n, we can find out rho L by pi ab. This will be the answer. Let me write it clearly, r equal to rho L by pi ab. Fine, this is the answer. Thank you.